All right, today in this set of notes, we're going to be covering an introduction of stoichiometry. And what stoichiometry is it's a study that relates the amount of reactants to the amount of products in a chemical reaction. And it's all based on the law of conservation of mass, which states that mass can't be created or destroyed, it just changes form. So that means the mass of our reactants has to equal the mass of our products in a chemical reaction. Stoichiometry is something that's useful when we want to predict the amount of product that we're going to make, or we want to figure out how much of each reactant we're going to need for a reaction. It's also useful whenever you're really making conversions or you're following a recipe. It's the type of math used in those cases. One of my favorite examples is a sandwich example, and I really like grilled cheese. So when I make one grilled cheese sandwich, I like to use 2 slices of bread and just a simple 1 slice of cheese. And that allows me to make a grilled cheese. But let's say I have a couple friends over and I want to make 3 sandwiches. I have to figure out how much bread and how much cheese I would need to go with that. So if I'm making 3 batches or 3 times as many sandwiches, I'm going to need 3 times as much cheese. So it would be 3. And I would need 3 times as much bread. So 2 times 3 would be 6 bread. So that's the general idea of the math behind stoichiometry right there. If we look at it in a chemical equation, it's going to look a little bit different, but a chemical equation is very similar to a recipe. So we've been talking about coefficients here. We got a 2 there. If there's no coefficient, we assume 1. And we got another 2 over there. So when we've been thinking about coefficients, we would have called this 2 molecules of water. Plus, if there's no coefficient, it's 1 molecule of oxygen would become 2 molecules of, this is 2 molecules of H2, 2 molecules of hydrogen, 1 molecule of oxygen would become 2 molecules of water. But as chemists, we deal with things on a larger scale. So we're going to think of these in terms of moles. So we can now think of it as 2 moles hydrogen plus 1 mole of oxygen would become 2 moles of water. And if we want to use the same analogy up here with 3 sandwiches, let's say we had some friends over and we needed all of a sudden 6 moles of water, well, we would just need 3 times the amount of oxygen, 3 moles, and we would need 3 times the amount of hydrogen, so 6 moles of hydrogen. So in order to do this, what we're using is a mole ratio. Because the math does get harder and we will be using decimals, so mole ratios become essential. So a mole ratio is a ratio between the number of moles of any 2 substances in a balanced equation. So going back to our sandwich example, if I wanted to find my mole ratio of sandwiches to cheese, how many sandwiches can I make with a certain amount of cheese? My ratio would be, I would just look at my coefficients here, 1 to 1. 1 sandwich to 1 cheese. And that just means I can make 1 sandwich for every 1 piece of cheese that I got. If we wanted to think of another example, we could have done a bread to cheese. So we could have our ratio here. We would need 2 slices of bread for every 1 cheese. And we could even set this up in the terms of a math problem. Let's say I had 1.5 pieces of cheese, and I wanted to make the most amount of sandwiches. I got 1.5 cheese. I want to make the most amount of sandwiches as I possibly can. How much bread will I need? I just plug in my ratio, because I need twice as much bread as I do cheese. So 1.5 cheese times 2 divided by 1 would mean we need, I'm running out of room here, 3 slices of bread. So looking back at our hydrogen reacts with oxygen to produce water, some mole ratios here might be, if I had a certain amount of water that I wanted to produce, and I had a certain amount of oxygen, I would have, 1 oxygen on top, and I would put my water on the bottom. And that could also go the other way around. So if I know I'm starting with a certain amount of oxygen, and I'm trying to figure out how much water I'm trying to make, I could put the mole ratio like this as well. So it could work either way. It just depends what we're starting with and what we're ending with. Whatever we're starting with will go on the bottom, and whatever we're trying to find will go on top. So now to jump into how to solve a whole mole-to-mole stoichiometry question. I wrote the steps out here, so we have all 4 steps. The first thing is we need a balanced equation. So if we were already given a balanced equation, we could skip past that. But if it's not balanced, we need to find a balanced equation to get those coefficients. Next, we got to read the question and identify the substances we are starting with and the substance that we're going to compare it to. So that's sometimes a bit of a challenge. Then we're going to find our mole ratio. Remember, that's going to be whatever substance we're trying to find on top and whatever substance we're starting with on the bottom. And then we multiply the starting amount by the mole ratio. So let's jump right into a couple examples here, starting with example 1. I know I'm going to balance this out first. So I got magnesiums and oxygens. I always start with thinking of we got 1 of each of these and how much magnesium and oxygen we have. So from this, I got 1 magnesium, and from this, I got 1 times 2 oxygen atoms. And because of the law of conservation of mass, I need the same on this side. But right now with 1, I'd have 1 magnesium and 1 oxygen. So that is not balanced. My magnesium is balanced, but I need more oxygen on my right side, so I will erase this coefficient and make that a 2. And in doing so, I'm adding another magnesium and another oxygen. So now my oxygen are balanced, but I need more magnesium here. So there. Now we got a balanced chemical equation. So now if we read the question, it says, how many moles of oxygen are needed to produce 12 moles of magnesium oxide? So I'm given this number right here, 12 moles of MgO. So even though that's my product, that's going to be the number I'm starting with. And I'm looking for moles of oxygen. So even though that's my reactant, that's what I'm trying to figure out how much I need. That's what I'm trying to figure out. So that's going to be on top of my mole ratio. So as I write this question out, I'm going to start with 12 moles magnesium oxide, and I'm going to write my mole ratio out next. So I'm starting with magnesium oxide, so I would have 2 MgO on the bottom, and I'm finding oxygen, so 1 oxygen on top. And then I would just multiply across. So 12 times 1 divided by 2 would mean I would need 6 moles of O2. And if we think about it, that makes a lot of sense. I will make 2 magnesium oxides for every 1 oxygen molecule I have. So that's our mole ratio, and that's how it works. So we got one more example to look at here, and then we'll end it. So again, first step, balancing this equation. We got H2 and N2 becoming NH3. So again, we got just 2 different elements, H and N, H and N, 2 H's, 2 N's, 1 N over here, and 3 H's. So I am going to balance out my nitrogen first. So I got 2 on this side, 1 on this side. I'm going to need more NH3. So if I put a 2 there, I will have to add another nitrogen and 3 more hydrogen for 6. So I want 6 hydrogen on my left side now. And for every time I increase my coefficient by 1, I'm adding 2 hydrogen. So if I change this to a 2, I'm just going up by 1. That would only go up 2. So I'd have to go up by another 1, so up to 3 to hit 6. So there we go. We got our balanced chemical equation. So now let's read the question, figure out where we're starting and what we're trying to find. How many moles of NH3 would be created from 5 moles of H2? So we're starting with this amount right here. And we're trying to figure out how much moles of NH3 we're producing. So let's start by writing this out. 5 moles of H2. And if I look back at my chemical equation or my recipe, I'm going to need 3 moles of H2 for every 2 moles of NH3 that I'm going to be producing. So let's figure this out here. So 3 H2 goes on the bottom, and my mole ratio on top would be 2 NH3. So I multiply across and divide by the bottom. So 5 times 2 is 10. Divided by 3 is about 3.33. It's going to be moles of NH3. And that would be our answer there. So that is, in short, how to work through these stoichiometry questions and the mole-to-mole stoichiometry questions, and a little bit about what stoichiometry is.